1.8, number 7. Several people had some issues with number 7. They didn't like this one very well. So there's a straight line path. Okay, so I'm just going to kind of draw it as a road that goes on. And there's some place where it's 0. And we have an object moving along this path. I'm just going to make it a little car. And it's moving along the straight path, the origin, and it is known at 9 seconds. So 9 seconds into this, nothing to do where there. The object's position at 9 seconds is 4 feet. So over here, we're going to go out, mark it 1 foot, 2 foot, 3 foot, 4 foot. So my little car is sitting here, and this is the positive direction. So we make the headlights pointing out that way, and it looks like it would be headed that direction because that's the positive direction. But they say, furthermore, the object's instantaneous speed at 9 is negative 1.2 feet per second. Oh, it's backing up. It's going backwards at negative 1.2 feet per second. So this car is going this way. In a second, it will go about a foot and 0.2. So it'd be back in here someplace in a second if it maintained that speed. Okay. Estimate the position of the object at 9.34. All the information they've been giving us is at t 9 seconds. So our linearization will be based on 9 seconds. A equal 9 seconds. And it will be the slope, or f prime, which is velocity. Oh, that was negative 1.2 feet per second, times, and this is actually in time, so I'll put t's here, minus 9 seconds, plus, where was it at 9 seconds? Oh, it was at 4 feet. Okay, now they want to know at 9.34. So we put 9.34 in here, subtract 9, we get, oh, the time changed by 0.34 seconds. And this was in negative 1.2 feet per second. And if we multiply those, we find out that if it was going at a constant speed, it would have moved, see, negative 1.2 times 0.34 seconds, that's how much the time changed, it would have moved negative 0.408 feet. Negative 0.408 onto the 4 feet it was already out, so it would have been at 3.592 feet. 3.592, somewhere in here. Like I said, it would be moving backwards. That's if it stayed at the same speed. However, furthermore, the object's instantaneous velocity and its acceleration is 0.08 feet per second per second. So this doesn't stay the same. Every second, this is increased by plus 0.08. So if you add that to this, we get a number that's less negative. So it's slowing down in its backwards motion. It's slowing down. It's accelerating in the positive direction. So it's coming this way, but it's slowing down, and then it's eventually, if it comes back far enough, it'll turn around and go the other way. So in everyday language, describe the behavior as it's moving. It's going backwards, but going backwards at negative 1.2 feet per second at this point, but then as it continues, it slows down because it has this positive acceleration and it's moving in the negative direction. So it's slowing down in the negative direction, and eventually it'll come to a stop and then go in the other direction if this is maintained for a while.